Hello and welcome to Learn Data. It's great to have you on the channel, and today we'll continue learning about pandas. In this video, we'll specifically look at what are categorical variables, and this will be in next 2 or 3 videos, I think, this topic. In specifically, we'll be also looking at how to create categorical variables in a series or a data frame, what are ordered versus unordered categories, and how do we convert the categories back to the data, and also look at the descriptive statistics, such as how do we get counts for each of the categories that were created. So before we start coding today, we'll look at few examples here. Let's say we have a data set with these 3 columns: customer ID, visits per week, and customer satisfaction. Now the first customer has 6 visits per week and has given the business a customer satisfaction rating of poor. The second customer, however, has 36 visits per week and has given a rating of excellent. So this last column, customer satisfaction, has several different categories, and if we look at those, they are poor, excellent, average, bad, and good. Now we can also arrange them in a specific order based on the number of stars they may have given. So that makes them ordered categories. So the bad would be the least number of stars, and the excellent would be the most number of stars. So we have bad, poor, average, good, and excellent. So because we were able to put an order to those unique categorical values, therefore that particular column of customer satisfaction could be treated as ordered categories. Moving on, what would then be unordered categories? Let's add another column, city, and let's say we know the cities where they belong. So the first customer is from Sky City, second customer is from Road City, and so on and so forth. So we have 3 cities: Sky City, Road City, and Rain City. So those city names do not have any specific order. Even if we arrange them in a specific order, they do not convey any additional meaning, and therefore we leave them as is and use them as is. So those would be unordered categories. Okay. Moving on, we can also add codes to each of the categories, and those could then be used as coded categorical variables. So here we have the ordered categories that range from bad to excellent, and we can give each of those categories a number from 0 to 4. And as you can see, the column in blue then lists the coded categories for the customer satisfaction. So depending on the type of analysis, then those codes could be used as needed to segment the customers. And finally, let's look at what descriptive data we can get out of the categorical variables column. Here, as you can see, this is the output from Jupyter notebook, and if we'll use the .describe command for against the category column, we get the counts, unique number of counts, and which is the top category and what is its frequency. So here, count, there are total number of 6 records. Unique records, we have 5. So those are the 5 categories, and the top category, which means the category that has the highest number of highest frequency, is poor, because it occurs 2 times, all other categories occur only once. And finally, frequency is the number of times that top category appears. So in this case, this is 2. Okay, so that was kind of the conceptual idea about what categorical variables are and how they work. Now let's go into Jupyter notebook and see live examples of how we can create these. Here I've already imported 3 libraries. We do not need the last one, so I'm gonna delete it. So we have NumPy and Pandas, that's what we need. And for data, I've created a series A, which we can see here. Then also have a series DFR, which is this one, and then there is a series a DataFrame DFC, and above was DataFrame DFR. What I'll do is I'll copy these data frames in the description below of this video, so you don't have to type it. You can simply copy paste it in your Jupyter notebook. So let's get started with coding. First is let's see how you can create categorical variables in series. Now the series that we have is the series A, which has MNOP and MN. Now if we were to convert this to category, what we would type is, or let's say A is equal to pd.series, and I'm going to go ahead and just copy this. The easiest thing is to just copy that part, paste it here, and then here we can say dtype is equal to category. And now when we run this, as you can see, earlier it was data type object, now it's a data type which is category. And below we also see the list of categories that are in that particular series, and if you notice, it is unique are there. So M appears here twice, N appears twice, but when we are listing the types, the categories, categorical items that are in that series, each item appears only once. So we have 4 of them in this one. Moving on, let's look at a data frame. Let's say we create a data frame df, and here we can go ahead and use the exact same series. So we'll call it column A has that particular series. Now this is our data frame with column A. If we were to go ahead and add another column which has exactly the same data that is in column A right now, and call it a column B and convert it to categorical variable, we can do that. So let's say df and df open square bracket colon quotes B, and then here we type df a close square brackets as type category. Now when we run df, this is the new data frame we have, and if you look at the data type for this one, we see that the column A is an object column, whereas the column B is now a category column, because we created that using this particular command as type category. Next, let's look at how you can use binning. And binning is really helpful if we have a data set which has a numeric column that needs to be converted into a categorical column. For example, here we have the data frame DFR, where we have the numeric column which is rainfall in millimeters per hour, and if we need to convert the data in here to categories so that we can segment the geographical IDs that are in the very first column, geo IDs, then we can do that. And the way we would do that is by creating bins. So let's say we create a variable that has a list, and in here we specify the bins, so 0 or 0.01, 2.5, 10.0, 50.0 and 100.0. So these are just the ranges which would enable us to categorize these in these millimeters. So areas that get 0 to 0.01 to 2.5 millimeters of rain per hour versus areas that get 50 to 100 millimeters of rain per hour. Now, once we have this variable, we can also go ahead and create labels. So let's do that. Now for labels, we'll use list comprehension that we've seen in previous videos. The way this works is we would type for I in range here we are going to use the range which is in the RR variable, and -1 because we want to stop at the last, before the last loop, so it doesn't go out of bound. And for each of those iterations, what we want to do is create a label. The label would have the range, which is the 0. 0 is the first number. I'll explain how this works. 0 and then 1 and dot format. This is a different way to write a print statement, and I'll explain that in just a second. So RR is 1, and we don't need two brackets there, just one. And the second one is RR I plus 1. Okay, so the way this works is here we have curly braces 0 up to curly braces 1 dot format RR1. So this, the value from RR I goes in 0 because that's in the first position, and then this is in the second position, that goes in curly braces 1. So what we will get here is, first would be range 0.01 up to 2.5, and the second one will be 2.5 up to 10, and that's the labels, and we are going to use that in a command called pd.cut. So if we have dfr and we create a new column, let's call it rain underscore category, and pd.cut dfr, and the column we are going to use is rainfall underscore millimeters per hour, and here we specify the bins, so that's going to be the RR. Right is equal to false, and labels is equal to RR dot labels. So once we run this is going to create the column DFR. Now the error that we have, list object has no attribute labels, that is correct. So I made a mistake here, it should be RR underscore labels. Now if we run DFR, here we can see that now we have a new categorical column created here. If you look at the dtypes for this particular data frame, we can see that the rain category is a categorical column, whereas the millimeter rainfall underscore millimeters per hour continues to be a float data type. So that's one way to add a categorical column based on a numeric column in a data frame. Now there's another way in which we can add another column, categorical column 2, to this particular data frame, and that is more like adding it manually. So let's create a variable rcat is equal to pd.Categorical, and in this particular command we are going to specify a list of what we want those categories to be, and we are going to say medium for medium rainfall, light for light rainfall, and the order of these categories that I'm typing right now, I've already looked through the data frame above, and based on these ranges I've already checked that medium would be the first one, light would be the second one, so on and so forth. So if we know these order already, then it can be easily added to an existing data frame as a categorical column. So we have violent, and the last one is heavy. So once we have this, we can now go ahead and add this to our data frame. So DFR, we can create a new column which is, let's call it rain category 2, and we can assign the output of rcat to that. And now when we look at DFR, we can see that we have additional column rain category 2 that has medium, light, violent, heavy, these categories. So just based on this one column, we are able to create two types of categorical variables. Again, if we look at the d types of this particular data frame, we can see that it now has two categorical columns in addition to the existing two columns that we started with. So moving on, let's look at how we can add or create a data frame with a categorical column while we are building the data frame. So adding a categorical column while creating a data frame. Now we have seen part of it earlier for series, and it's similar way that it works for this one as well, where we are going to use the dtype category. So the dfx, I thought we had that in the data frame. Anyways, we can create one. So dfx is equal to pd.DataFrame, and we'll give this data frame two columns, say x, and x could be m and o. Let's say m, then n, and then o, and after this we have a second column y, which is could be same or different. Let's create o, p, q. Now here we can specify the categories in this command itself. So I'm going to delete this curly brace, and over here we can say dtype is equal to category. And now if you look at dfx, this is the data frame we have, and if you look at the d types of this particular data frame, we can see that both the columns in that data frame, or all the columns if there were more, would have been the categorical columns. Now in a situation where if a data frame was already created, and for example we can use this same data set here and create another data frame dfx2 without the category mentioned there. Now if you look at the data types for this one, it won't say category, it will say object. Now if we want to convert such a data frame into a categorical data frame, then to do that we have to specify astype. So what we would say is dfx2 is equal to dfx2 dot as underscore type, and then we specify the category. Now when we run this and run for dfx2, we see that there is an error. So sorry, this has to be astype. And now if you look at the d types for this dfx2.dtypes, you can see that it's a category. So that's another way in which we can convert a data frame into a categorical data frame. There is another method in which we can create an instance. So using an instance to create categorical data. How do we do that? For this we need to import a new library. So that would be from pandas.api.types import categorical capital D type, and then let's use the series that we already had earlier. So I'm gonna scroll up, copy this and bring it down over here. Okay, sorry. Okay, that's good. That's the series we have, and for this we are going to create a new variable cat underscore type, and that's going to be where we first use the instance. So categorical data type, and categories could be, so out of all the categories that we have in the series A, we can pick just maybe 3, M and O and P, and then let's say these are ordered categories, so we can specify that ordered is equal to true. Now that is, so here we have created instance category cat underscore type, and that is what we can use to convert the data in series A to categorical variable. So if we say, sorry, so here undo, let me undo that, a underscore cat is equal to a dot as type cat underscore type. And now if you look at a underscore cat, we can see that the the items that were in the series A are now converted to categorical variables based on cat type, and those that are not there are mentioned as NaN, others exist as a category. And below we also see that there are unique categorical values, 3 values M and O, sorry, MOP, that are specified here. So similar to series, we can apply the same method to a data frame. So if you look at the data frame, DFC is equal to pd.DataFrame, and here let me see if we already have created. Okay, so we have the data frame DFC already created, but we do not want to use that one, so I'm gonna create another data frame here. Let's say DFV and pd dot let's go ahead and delete this to avoid any confusion. DFV is equal to pd dot data frame, and here we are going to specify a column name X and specify another column name Y, and here we'll say list. So this is another way to create a list. So instead of typing each and every one separately, if you just type list and the string and quotes, you can create a list very easily, like so. So for list column Y, let's go ahead and create another list, which is say MOPQ, and that's the second one we have, DFV. So that is our data frame. I forgot the comma there. That's our data frame. Now what we can do here is use the same category type that we created above in here. So we say df underscore cat, that's the new data frame, which would be dfv dot as type cat underscore type. And here if we say df underscore cat, this is the new data frame that we created with columns X and Y. However, this now has NNs in it because those categories are not available in this particular variable cat type. It has only MOP, and therefore everything else gets converted to NaN. Now if you look at the dtypes for this one, you see that both the columns now have become categorical variables. So that was those were a couple of ways in which we can use instance method to create categorical variables both in series and in a data frame. Now let's look at how we can create categorical variables using codes that we saw earlier in the slide. To do that, let me create a heading codes, and for this, now we are going to use the data frame that we had earlier, DFC, because we already have the codes created here, which is, as you can see, in this particular column. And to create a new column, which is a categorical column, we can say DFC, and let's say customer categories, and here we can say pd.series and then pd.Categorical dot from underscore codes, and here we can say DFC, the code column that we have created, and then in here we can also specify the categories. So the categories, as we had typed earlier, for rain, this would be for customers, and let's say they are bad, poor, and then we have average, good, and finally we're excellent in there as well. So those are the categories that we are creating from the code column that we have here, and putting the output of that in a new column in the same data frame that is called ccat, that's the customer categories, and it will have these values. So if we run this and look at the DFC, as we can see here, we are able to add a new column here, which is customer categories based off of the code column that we had, and as it's same as the customer satisfaction column that already exists, but this is just to show you that there is another method which can be used to create categorical column. Now moving on, let's look at how we can use the series as well. So how to get the original data back from a categorical column. So let's create a heading, and it is straightforward, at least in this simple example, where we have the series A, which we know is not a categorical. So we'll go ahead and create a categorical series, a.type category as type and a2. So now as we see, this is a category, and if we want to convert it back, so we can go ahead and create another series and use the a2 and say as type, and this time we can specify it as a string. Now when we run this, we can see that we were able to convert the categorical series a2 into object data type a for a3. Similarly, that can be replicated in a data frame as well. Now moving on, let's look at some equality between these categorical variables. How does it work? So if we have let's say a categorical data type a1, which is categorical data type, and let's give it values a, b and c, and let's call it ordered is false. Now we have this category which is a1. Okay, now if we were to compare a1, if it is equal to another category, same, we would expect it to be true, and it is true. However, there is a catch. If we change the ordering, if we say this is true, then it doesn't return as true, it doesn't return as equal, and that's because if it is ordered, then the value that each of these levels in that category would carry could be different than what we had created earlier when we considered them to be as unordered. So that's just one thing to remember when comparing different categorical columns together using booleans. Finally, let's look at how we can use descriptive statistic. And this is just one simple command to get us the counts. So the data frame that we have is this, and if we have a large data set with thousands of rows, and we are wondering what is the proportion of each customer category in that data set, how can we find that very easily? And that is using the describe command. So if we type dfc, and here if you say customer satisfaction dot describe, here we very easily can get the counts, which is the total number of records that have the category, then total number of unique categorical items that you have that are there in the data set. Here there are 5 of them, and the top category, that is the category that has the highest number of customers. In this case is poor because there are two, it appears twice in this data frame, and below we get the frequency of that, which is 2. So that was it for this video. I hope you learned about what categorical column categorical data is, how it works, how to create categorical data, and also how to go back from categorical data back to the normal object data type, as well as how to look at simple descriptive statistic for a categorical column. We'll continue this discussion in next video and look into much further detail on different methods that are available within Pandas. And I'll see you all in the next video. Please like, share, and subscribe if you learn from these videos and enjoy the content. Thank you.